For this set of notes, we're going to be looking at the measures of center, and then in the next set of notes, we'll look at the measures of variation. So the measures of center typically relies on the central tendencies of the data that we're presented with. What's kind of the average, what's going on around the middle of this whole set of data that we're presented with. And the first one that we're going to talk about is the mean. We're going to talk about the mean, the median, and the mode in this set of notes. One thing we want to also pay attention to is that the mean and the median will only apply to quantitative data, whereas the mode can be either quantitative or qualitative. The mean, in general terms, is simply the average of the set. So you would just take all the values in the set of data, add them up, divide by however many numbers there are in the set, and you've got the mean. We're going to use Google Sheets a lot from here on to do a lot of these calculations. So we're given in example 1 the two data sets, the first one and then the second one there, and we want to find the mean of each of the two sets. And then it also says to interpret our findings. So that's where the difference is between just a traditional math class, like I mentioned today when we had our meeting, and a statistics class. So we have to look at what the context of the problem is. And in this particular problem, we're talking about a firm that employs a few senior consultants who make between $800 and $1,050 per week, a few junior consultants who make between $400 and $450 per week, and then clerical workers who made $300 per week. The firm acquired more employees during the first half of the summer than in the second half, and then the table lists the weekly earnings for the two halves of the summer. Find the mean of each of the two data sets, and then interpret our findings. I'm going to go over here to Google Sheets. I've already put these data sets in. So all we have to do is at the bottom of the first column for data set 1, if you simply type in equals, and then we will type in average, parentheses, and then if you will highlight the entire set that you want to find the average for, we get 483.846. Well, since we're talking about money, we want to round that. So that's going to be 483.85. We'll do the same thing for the second set. So we're going to do equals, average, highlight the values, hit enter, and we get 474. So what this shows us when we go back over to our notes is for the first data set, there is an average of $483.85. And that's the average weekly earning. So that's average or mean weekly earnings. And then for the second set, it's $474. And it's the same interpretation. It's the average or mean weekly earnings. That's what the interpretation is, because we have to put some kind of context to our result so that we understand what that value represents. So in the first case, 483.85 in average weekly earnings. In the second set, 474 in average weekly earnings. The next measure of center that we're going to look at is the median. And the median is going to end up resulting in that middle value of the entire set of data. So if you organized it in order from smallest to largest, whatever number falls in the middle is going to be your median of that set of data. Now, in some cases, if the number of observations is even, so if you have, say, 4 observations, there is no distinct middle number. Let me just write this out so you can kind of see what I'm talking about. If we have 1, 2, 3, 4, if I wanted the median of that set, there is no number right here in the middle. So what you have to do on an even set of data is take the two middle values and average them. So in this case, we would add 2 plus 3, which is 5, divided by 2, and we would get 2.5. If the set of data has an odd number of values, it's always going to be that middle value. That's the median. So if we have 1, 2, 3, 4, 5, the median is the number 3. Again, Google Sheets will make these computations very easy. We're going to use the same sets of data from example 1, and we're going to find the median for each one of these. So let's go back to our sheet, and we're going to look at example 2. So I have the order or the values in here. All we have to do is type in equals median, parentheses, highlight the values that we're evaluating, and for the first set we get 400. For the second set we type in median, highlight it, and we get 350. So the median for the first set is 400, and the median for the second set is going to be 350. Now you'll notice here in this second set none of our values is 350. So what that tells me is that somewhere in the middle we had a 300 and a 400. This was an even set of data, so it took the average of those two middle values. So for the first one we have $400, and for the second one it's $350. And again, that's in this case it's the median weekly income, and that's the same interpretation for both. So for the first one, $400 is the median weekly income, and for the second set it's $350 is the median weekly income. If we scroll on down to the next set, we're talking about mode, and mode just looks for the number that appears, or the data point that appears most often in your given set. And again, Google Sheets will compute that for us. So if we go back to our Google Sheet and I go to example 3, if you just type in equals mode and then parentheses, put the values that you're analyzing, do the same thing for the second set, mode, parentheses, and we get 300 is the mode for both of these. So when we write out our solution, 300, 300. So both of them have a mode of $300. Now when we are comparing these, you can see right here, the mean, the median, the mode, they're often going to be different. Sometimes they'll be the same, but they should be somewhat close to one another in both cases. Here in the first data set, we see that the mean is larger than the median in both cases, in data set 1 and data set 2. The reason is that the mean is strongly affected by a few larger salaries. So the mean will be pulled in one direction or another. If we have a lot of small values, then it'll be pulled towards those smaller values. If we have a lot of large values, then our mean will be pulled towards those larger values. The median, however, is not affected by extremely large numbers or extremely small numbers. The median is just that middle value. It does not get impacted by the size of the values in the data set. The median is our preferred choice for the middle value for data sets that have some extreme values that are not typical to the remaining values within the particular set of data that we're looking at. So if you looked back at data set 1, we really don't have too many extreme values, but you do have that one value of $1,050. Granted, there's a couple that are pretty close. We have 940 and 800, but that 1,050 pulls the mean further up in the positive direction, as opposed to just looking at the median itself. And then you can see here in these three graphs the way that the data relates when we talk about the mean and the median. So on a right skewed set of data, the mean is going to be to the right of the median. In a symmetric set of data, the median and the mean are going to be approximately equal to one another. And then in a left skewed set of data, the mean will be pulled to the left of the median. Example 3, we have a student that takes 4 exams in a biology class. His grades are 88, 75, 95, and 100. Which measure of center is the student most likely to report? When we look at those values, and I didn't type this up, but if we looked at the mean, the median, and the mode of this set of data, we would find that the student's mean is greater than the median. So for this one, the student would likely report the mean of their grades. The National Association of Realtors publishes data on resale prices of U.S. homes. Which measure of center is most appropriate for such resale prices? And that one's going to be the median. Because when you're talking about home sales, if you guys have ever looked at a home sale guide, it'll talk about a subdivision perhaps, and the subdivision will have a median home price. The reason being is because you may have some really, really expensive homes in that subdivision that would pull the mean price way up, or you might have some homes that are in disrepair that don't have the same value that they should, and that would pull the mean price way down. So the median price is what most realtors are going to look at. In Part C, the 2014 Boston Marathon had 2 categories of official finishers. They had male and female. Of which there were 19,579 and 16,092 respectively. Which measure of center should be used here? Well, in this case, we're talking about the categories being male and female. So we're looking at their gender. We looked at this earlier. Mean and median are both quantitative values only. So in this one, we're going to have to look at the mode. Which one was repeated most often? Was it male or female? And that way we'll be able to analyze that particular center for the set of data. The summation notation is something that you've probably seen before. I mentioned earlier in our meeting, it's that the sigma, so it's that large Greek E, and it gives us a mathematical representation. We're adding up certain terms from one value to another, and we're going to add all those terms in between together. So the first thing I want to do, we're looking at back at example 3 with the exam scores, and we have that the exam scores for the student in example 3 are 88, 75, 95, and 100. For part A, it says use mathematical notation to represent the individual exam scores. So I'm going to use a notation. It's called X sub I, and that I is my index. So if I looked at X sub 1, that's the first score in the set, which is 88. If I look at X sub 2, it's the second score in the set, which is 75. X sub 3 is the third score in the set, so it's 95. And then X sub 4 is the fourth score in the set, which is 100. And that's it. That's all that sub I means is how many values there are in the set. In this case, we have 4 values. Now we want to use, for part B, summation notation to express that sum of the 4 exam scores. So it's no different than just saying X sub 1 plus X sub 2 plus X sub 3 plus X sub 4. But we can condense that. If we had a whole lot of values that we were adding up, say we had 100 values, we don't want to write out X sub 1 plus X sub 2 on and on and on until we get out to 100. We can condense that with mathematical notation using the summation notation. So the first thing we start out with is sigma. Our index, our I, starts at 1, and I wrote down 4. It starts at 1, and then it goes to 4. So then our 4 is the maximum value for the summation notation. And then we just simply write out X sub I over here to the right. So what that tells me is that when I is equal to 1, I take that first value, and then I bump this index up to 2, and I add that second value, then I bump it up to 3, and I add the third value, and then I bump it up to 4, and I add the fourth value. I don't go beyond 4 because this sum is capped at a maximum value of I is equal to 4. So that's just a abbreviated way to write that notation without having to write out every single term being added together. The next thing we're going to look at is what we call the sample mean. The sample mean is the sum of all the values in the sample set divided by the number of samples, and that's what we see right here. But notationally in statistics, what we use is this X bar, and that's exactly how you say it. It's X with the line over it. X bar represents the sample mean. Later on we'll look at the population mean, and everything has a different notation so that we can distinguish between samples and population. So for this particular one, we're talking about samples, and so X bar is the sample mean. and it's simply just adding up all the values in the sample set, dividing by the number of samples in the set, and you'll come up with the solution. So let's look at example 5. We have this paper. It's called Correlations Between the Intrauterine Metabolic Environment and Blood Pressure in Adolescent Offspring and Diabetic Mothers. I don't know why all these academic journals have such long titles, but that's what the title is. The authors present findings on research on children of diabetic mothers. Past studies showed that maternal diabetes results in obesity, blood pressure, and glucose tolerance complications in the offspring. The table that we're provided represents the arterial blood pressures in millimeters of mercury, or mmHg, for a sample of 16 children of diabetic mothers. Determine the sample mean of these arterial blood pressures. I've already put this data into Google Sheets for example 5. Here's all the data that we were presented with. We're talking about a sample mean, so it's still just the average when we're using Google Sheets. So average, then we do our parentheses, highlight the values, and hit enter. We get 86.18. And we will go back to our notes. I got to turn off the highlighter. 86.18. That is the sample mean for those arterial blood pressures. And what we also want to indicate is that this is X bar. Okay, so when we look, if somebody were looking at our data and they saw that X bar, they would know then that all of these values given here in this table represent a sample of that set of the overall set. It's not the whole population. So when they see that X bar, it indicates that this is a sample set of values. So that is the low down, dirty, quick and easy synopsis of the measures of center. I'll get the measures of variation out here shortly, but I hope that this makes sense to you. Again, if it doesn't, please ask questions. I'll be happy to clarify anything that I may have glossed over too much or didn't expound on enough. So if you guys need me, you know how to get a hold of me, and I hope you all have a great day.